Module 6 GCL P2P and Streaming. Here is the outline. In this module, we will introduce these advanced functions in Aiden, including data streaming, peer-to-peer, and the GCL function. Here are the objectives you are expected to understand in this training module. You will be able to implement these three functions and know their setting. Before talking the data streaming function in Aiden, let's see the data flow in Ethernet communication first. The first one is pulling, which means the controller will send command to ask I/O module. The I/O module will reply to the controller. The second one is data streaming, which means the I/O module will periodically update data to controller without receiving command from controller. The last one is event or alarm. The I/O module will update data to controller where there is an event triggered. Unlike the mobile's TCP protocol communication, which requires an active pulling for the response, the data stream function allows the remote I/O to automatically update the I/O status to the host. The data stream function means Aiden will periodically send data to the assigned IP by using UTP. User can decide which host will receive the I/O data from Aiden, and also the sending interval. Both host IP address and the sending interval can be set in utility string menu. Besides, the maximum number of hosts for Aiden to send data is 8. That's also the limitation of maximum connection number for Aiden, which only allows 8 clients to connect to Aiden. In Aiden utility, we can monitor data stream and display the real-time I/O data. Below are the steps for monitoring the I/O data. Go to Tools and then select the menu Monitor Stream Event Data. Select Aiden module, then click the Start. As you can see, the analog input value of all channels are streaming back from Aiden. For AIO module, all the data received in the host are in hexadecimal format. Here we can do a quick data stream demo for using Aiden 6250. The demo topology is as below. The device must under the same network domain with the PC. The utility will act as the controller to monitor streaming data and get the real-time I/O data from Aiden. Here are the settings I have to enter in utility, including the host IP and the data update interval. Last, by using monitor stream and event data function, the logic status of all channel and the counter value are streaming back from Aiden. The DIO data received in the host are also in hexadecimal format. So the value in DI here is 111, represented in binary format, which means DI channel 0 to 3 are logic high. However, the counter value stored in DI channel 0 is in decimal format, which shows 5 times here. In the past, we usually use a controller to ask input module status, then pass the status to output module for controlling. But with P2P function, you can easily let input module send signal to output module without having a controller. Frankly speaking, peer-to-peer function is to pass the input module raw data to output module register address. So, When the input module, AI or DI, sends a signal, it can pass this signal to output module, AO or DO, which can instantly control your device. By using P2P function, it can realize the direct synchronization for I/O status between input and output module. In summary, P2P is to pass input module raw data to output module register address. And only AI/DI input module have P2P function. If you take a DO and AO module, the menu for setting P2P function is locked. This slide shows a real application example of using Advantech P2P application. In Beijing Olympics Water Cube Stadium, we use Advantech to control the video display on and off through internet. As shown in slide, when we press the button, Advantech will detect the DI change, then send a signal for the other Advantech's DO channel to control the display. That's how P2P can leverage the existing Ethernet network to achieve remote control application and provide a low-cost system with easy installation advantage. There are two modes of P2P function. The first one, in basic mode, is one-to-one module with identical channel number mapping. Example, AIO channel is to AO channel 1. In advanced mode, you can use different channel number mapping between different input and output module. For example here, the AI channel 1 is mapping to AO channel 3, and AI channel 2 is mapping to AO channel 6. Let's see how to set P2P function in Advantech utility. This picture shows the basic mode of P2P function setting. User could decide whether to send the data periodically or send data based on the following: when DI logic status is changed, or when AI change over deviation value. This slide shows an easy way for P2P debug. In the P2P setting page, you can type host IP for the destination IP. Then go to the Tools menu, monitor P2P for viewing whether Advantech is setting data. If there is no data, please check P2P port number setting is correct or not. What is GCL? GCL stands for Graphic Condition Logic. Let's see these two pictures first. The last one shows user develop and run the logic rules in the controller. However, with GCL, user can run simple logic in the I/O module, so no need to use a controller. The benefit of GCL is shown below. It is straightforward programming, and you can cascade logic rules or use parallel rules for flexible control. Let's take a look at the GCL features. The GCL has a flexible user-defined control logic, and it can be preset in the Advantech.net utility. And logic rules are directly programmed in the I/O modules without another controllers or something. And you could execute the logic rules to process different actions. Here is the GCL configuration page in utility. After clicking the GCL icon, we have to enter password for going to GCL edit page. The step of GCL function setting are shown in the picture. Click the program button first, then click the rule 1 to edit. Next is to click enable rule to enable your setting. The last step is edit input and logic gate and output configuration stage, respectively. As shown in the picture, each single logic rule in GCL requires 4 different configuration stages. It's easy to set a GCL rule by double-clicking each item in the 4 stages. For example, by double-clicking one of the 3 input channels, user can configure this channel to DI, DO, or timer, and so on. The GCL output action definition can be defined by user. For example, user can set a trigger action by receiving the logic trigger value, just like this picture here. This page shows the concept of logic rule cascade. User can cascade up to 16 rules in each module. Each logic rule will execute to process different actions. There is an example of logic rule cascade. If either 1 or 2 AI channel rating voltage between 3 volt to 5 volt and passing an OR logic gate, the output value is logic true, so DO will generate a high signal. The detailed setting for this example is shown in the following 2 pages. Here is Rule 1 and Rule 2. And here's the setting for Rule 3. The GCL Cascade rules can not only apply in single module, it can also apply across different modules. Just like the below picture, the output can be local or remote module. Let's see an example of cascade rules across different modules. Similar to the previous example, if either one of the AI channels in Module A or Module B reading voltage between 3 volt to 5 volt and passing an OR logic gate on Module C, the output value is logic high, so DO in Module C will generate high signal. Here we will introduce how to manage your GCL project. GCL project can be exported or imported as file. Here we will introduce how to manage your GCL project. GCL project can be exported or imported as file. For configuration, you just click the GCL project content to read all the logic in the table. Click the disk icon to export project, and click the folder icon to import project. There are some notes for the module that are not support GCL or not fully support. The first one is Advantech. It does not support GCL because it's a PID controller. The second one is Advantech. It can only be the receiver of the GCL. And the last one is Advantech because it is a thermocoupled input module. Here are the port settings for these functions. For data streaming, we can change target port. For P2P or GCL function, we can change target or local port at the same time. Here, we are going to make a brief introduction of these 4 functions in GCL. The first function is timer, as you can see in the picture. When GCL Rule 1 condition is satisfied, the timer will be triggered. The user can set a condition of timer to trigger another component. Next one is counter. There are different behavior for counter input and counter output. Please check the DI setting in utility. User to need to set the corresponding DI to counter mode. Here is the message function. This message will send by UDP and use the same port like data streaming. The last one is the flag. User can use controller to control the status of their flags, then make the GCL logic become effective or not.